Okay, so in today's video we want to have a look at, begin to look at sort of multi-step probability situations, so where there's more than one step to the experiment and thinking about how we can represent and organise that information so that it then allows us to calculate probabilities. As I said much earlier in this topic, one of the biggest challenge in probability problems is to work out how to organise the information so that then you can go on and solve the probabilities. And usually once you've got your information organised, whether that's via some sort of table, Venn diagram, we'll look at tree diagrams in the next video, then once you've done that, the answering the actual probability questions becomes very straightforward. Okay, so a table can be a good way to organise information when there are two steps. And here I'm not talking about a two-way table or a Carnell map that we've looked at in the last few videos. I'm talking about different kinds of tables. In particular, tables where we want to make sure that every cell is equally likely to happen in the table. If we do that, then calculating the probabilities is very easy. These are limited though to problems where we only have two steps, because in a table we only have two sides to the table, two dimensions to the table, by which we can represent information. In the next video, as I said, we'll have a look at tree diagrams, and obviously we could have more than two stages in a tree diagram, so that would be where we would go if we had more than two steps. You could possibly also use a tree diagram for some of these, but actually quite often there are things where there are a lot of outcomes at each option, and that would make quite a big and unwieldy tree diagram, and actually the table is a neater and more concise way to represent the information. Okay, so let's have a look at example 1. We have a standard die is rolled and an unbiased coin is tossed. Use a table to list the sample space. Okay, so this is another way to really make sure that you are not missing any possible outcomes when you're trying to consider the sample space. Okay, so we've got our two different things that can happen on each side of the table. So I'm going to put my coin going this way because there are only two outcomes, heads and tails. Okay. And then I'm going to have my die going this way because there are 6 outcomes. So it's going to be a bit neater. So we go 1, 2, 3, 4, 5, or 6. Which means that the sample space is sort of head 1, head 2, head 3, head 4. You could write 4 head, it doesn't matter. Just some consistency though. Head 5, head 6. Tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Really, actually filling out the cells in that table is pretty tedious and unnecessary. And to that end, actually, sometimes we would use something called a lattice diagram in place of this. My apologies. Sometimes we would use a lattice diagram and we would say, okay, we've got head or tail, and then we've got 1, 2, 3, 4, 5, or 6. Oh, sorry, let me just space those a bit evenly. 6. And each of the nodes or the intersections in our lattice represents an outcome. So it's a way where you can easily sort of count the outcomes. You can still list them out easily because they're not complex. Tail 1, tail 2, tail 3, etc. Okay. So a lattice diagram can be an option too. Use a table to list the sample space. Okay, so that means our sample space is, head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. In reality, I'm perfectly happy with you leaving the sample space just listed in the table. Just be careful about what the question's actually asking you for. State the total number of outcomes. Okay, so in this instance there are 12 outcomes. So therefore, I'm thinking about probabilities. There are 12 equally likely outcomes. Our probabilities will be over 12. Find the probability that a 3 is rolled and a head is tossed. So probability of getting a head and a 3. So it really should be probably head and 3, technically. But it's okay to write that as H3 or 3H or whatever you want. There is one of those outcomes out of 12. Find the probability that a tail is tossed and an even number is rolled. So a tail and an even. Okay, so there are 3 outcomes out of 12 that are tails and even numbers, so that's a quarter. So once you organise your information, it's a little bit tedious to do that, but once you've done that, answering questions is very straightforward. Okay, in any table it's really important that it's set up in a way so that each cell is equally likely to occur. Otherwise, you're making it much harder to think through the probabilities. If the cells in the table can occur with different likelihoods, the benefit of the table as an organising tool for calculating probabilities is completely lost. Okay. So let's think about this one. 2 bags contain marbles of the same size and weight. Bag A contains 3 blue and 1 red marble, and bag B contains 1 blue and 1 red marble and 1 green marble. 1 marble is randomly selected from each bag. Use a table to list the sample space. Okay, so I'm gonna put bag B vertically because it's only got 3 outcomes, and I've got sort of a horizontal space here. Sorry, I need it to be smaller than that. Okay, so in bag B we can have a blue or a red or a green, one of each. So this is bag B, and I'm going to put bag A along the top. Now, along the top, bag A has 3 blue and 1 red marbles, so it's got 4 marbles, which means in order for each cell to be equally likely to occur, I still need 4 columns. But okay, they're going to be blue, 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 and red. Okay, so sample space is blue, 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 red, oops, blue, red, red, blue, red, blue, red, blue, red, red, green, blue, green, blue, green, blue, green, red. So actually in terms of listing your sample space, they're not all different outcomes, okay? You've got blue, blue, and blue, red, and red, blue, and red, red, and green, blue, and green, red. They're your only options, but they're not equally likely to happen, and therefore there's not, your probabilities aren't out of 6, your probabilities need to be out of 12. Okay, there's some repeat ones. So state the number of equally likely outcomes. There are 12 equally likely outcomes. There are only 6 different outcomes, but that's not helpful in thinking about the probabilities. Find the probability that 2 blue marbles are selected. So probability that we get blue and then blue. There are 3 outcomes out of those 12 outcomes with blue and blue, so that's a quarter. 2 marbles are selected with replacement from bag A. Use a table to list the sample space. Okay, so this time it's bag A and bag A. Okay, so, however, we need to think a bit about this, so I'm going to have to draw a bit small here. Okay, so bag A each contains blue, 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 and red. Blue, 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 and red. Okay. Okay, so the width replacement is important because that tells us when we take a marble out of the bag, we put it back in. So we then have the same marbles to choose from at our second selection. So if we think about this being our first choice and this being our second choice, it actually doesn't make any difference with the width replacement table. But we need to think a bit harder about, I think part C will ask us to do it without replacement. So if I draw a blue marble first, and then I put it back in, then I can still choose from blue, 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 red. Okay, so there's still all the options available. So blue, 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 red, blue, 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 red, blue, 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 red, red, blue, red, blue, red, blue, red, red. Okay, state the number of equally likely outcomes. So in this case there are 16 equally likely outcomes. A lot of them are repeated. There's actually only really, well, 4 different outcomes. Depends on how if you're interested, 4 different outcomes if you're interested in the order that you select them, only 3 different outcomes if you're just interested in what marble you get at the end. But 16 equally likely things. Find the probability that 2 blue marbles are selected. Probability of blue, blue. There are 9 outcomes out of 16 that are blue and blue. Okay, part C, 2 marbles are selected from bag B without replacement. Use a table to list the sample space. Okay, so bag B had 1 of each, a blue, red, and a green. Okay, blue, red, green, blue, red, green. So let's make this our first selection and this our second selection, because this time it's without replacement. Okay, so the problem here is if I draw the blue marble first, then the blue marble the blue marble isn't in the bag for me to draw again. So it's actually not possible to draw blue and then blue. Okay, so this cell is not possible. If I draw a blue marble first, I can then draw a red, so blue and then red, or blue and then I can draw a green. Blue, green. If I draw a red marble first, I can then draw a blue. But if I draw a red marble first, I can't then draw a red marble again because there's only one of each in the bag. So that cell becomes impossible. But I could draw a red and then a green. I could draw a green and then a blue, a green and then a red, but I couldn't draw a green and then a green because if I've taken the green out and I'm not replacing it without replacement, then I can't draw a green at the second selection. State the number of equally likely outcomes. So this time there's only 6 equally likely outcomes. Those 3 down the middle are not possible. There's only 6 equally likely things that will happen. Find the probability that 2 blue marbles are selected. Well, that's actually going to be, probability of blue is actually going to be 0 out of 6. So it's not possible to select 2 blue marbles with this model. So then, depending on what's actually of interest in the problem, we might actually complete the table differently. We might not just list the outcomes, we might actually then do something with them. So let's think about this one. We have an unbiased, so that means each side is equally likely to be landed on, 5-sided die, and it's rolled twice and the sum of the numbers rolled is calculated. Okay, use a table to help you list the sample space. Okay, so we're going to have our first roll and our second roll, roll 1 and roll 2. And we can get a 1, a 2, a 3, a 4, or a 5. A 1, a 2, a 3, a 4, or a 5. I'm just going to double up those lines there so that our heading row doesn't get lost in our outcomes. Okay, so we can get a 1, 2, 3, 4, or 5 on our first roll, and then we roll again and can get a 1, 2, 3, 4, or 5. It's a 5-sided die. Okay, now what we're actually interested in, I'm not going to write 1, 1, 1, 2, 1, 3, because what we're actually interested in is the sum of the numbers. So if I roll a 1 and then a 1, I'm going to calculate their sum to get 2. If I roll a 1 and then a 2, I'm going to calculate their sum to get 3. 4, 5, 6. If I roll a 2 and then a 1, I get 3, 2 and then a 2, I get 4, 2 and then a 3, I get 5, etc. And we can fill out the rest of the table with the sums, because that's what we're interested in this particular problem. Okay. So again, to list our sample space here, our sample space is going to be all of the numbers from 2 up to 10. Find the probability of obtaining a sum greater than 7. Okay, so the probability that the sum is greater than 7. Greater than 7 doesn't mean 7. So greater than 7 in this instance means 8, 9, or 10. So I can see that there are 6 outcomes that fulfill that criteria out of the 25 outcomes that I have in the table. 25 equally likely outcomes in the table. Find the probability of obtaining a sum less than or equal to 9 given that its sum is greater than 7. Okay, so we've got a conditional probability here. So we want the probability that the sum is, that the sum is less than or equal to 9, given that the sum is greater than 7. Okay, so given that the sum is greater than 7, so given that we are only looking at these 6 outcomes, what is the probability that the sum is less than or equal to 9? Okay, there are actually 5 out of those 6 outcomes that are less than or equal to 9. Okay. Example 4. 2 unbiased 4-sided die are rolled. The larger of the 2 numbers is recorded. If the 2 numbers rolled are the same, the sum of the 2 numbers is recorded. Okay, so again, this time we've got 2 4-sided die. No, well, 1 4-sided die that we roll twice. Doesn't matter, it's the same. Oh, no, there are 2 die, but it's the same problem. Okay. Okay, so we can get a 1, 2, 3, or 4 on roll 1. And, well, actually not. It's die 2 and die 1. Or 1, a 2, or 3, or 4 on die 2. Now, this time, again, I'm not going to write 1, 1, 1, 2, 1, 3, 1, 4 in the boxes because that's not what I'm interested in. This time, what is recorded is the larger of the two numbers, but if the two numbers are the same, then the sum of the two numbers is recorded. So if I roll a 1 and a 1, they're both the same, and so I calculate their sum, which is 2. If I roll a 1 and a 2, I record the larger of those two numbers, which is 2. If I roll a 1 and a 3, I record the larger number, which is 3. 1 and 4, I record the larger number, which is 4. If I roll a 2 and a 1, the larger number is 2. 2 and 2, they're the same, so I add them. 4. 2 and 3, the larger number is 3. 2 and 4, the larger number is 4. 3 and 1, the larger number is 3. 3 and 2, the larger number is 3. 3 and 3, I add them to get 6. 3 and 4, 4 is the larger number. 4 and 1, 4 is the larger number. 4 and 2, 4 is the larger number. 4 and 3, 4 is the larger number. 4 and 4, I get 8. So my sample space is going to be 2, 3, 4, 6, and 8. Not equally likely to happen. That's where the table's important, so I can see them as equally likely events. Find the probability that a number greater than 2 is recorded. Probability that we record something greater than 2. So greater than 2 doesn't include 2, so that's going to be everything from here up. So it is, what have we got, 16 outcomes in total, and 3 of them are 2s. So that means that 13 of them are not 2s. So 13 out of 16. If a number greater than 2 was recorded, find the probability that it was 4. Okay, so this is the probability of a 4 given that the number is greater than 2. So given that the number is greater than 2, given that we are only recording these numbers here, what is the probability that it's a 4? So that is 1, 2, 3, 4, 5, 6, 7 outcomes are 4s out of the 13 outcomes given from the condition. So the condition reduces my sample space just to those 13 outcomes. The probability that I get a 4 is 7 out of 13. Okay, so the work today is from exercise 8E, organising your information into tables to enable you to then answer the probability questions. In our next video, we'll look at tree diagrams, which could have been useful in some of these problems as well, but also they can be useful in other problems in addition to that.